Probably, though, the most potent effect of salt in terms of its power to drive intake is its ability to modify other tastes and flavors. So I love this quote: "Salt is the general of foods," and anybody that looks at recipes knows just the potency of salt in virtually every recipe. This is, again, an old study by Mary Ann Gillette at McCormick, but it is, I think, the most beautiful salt study ever done. So what Mary Ann did was to study people's judgments of salted and unsalted soups, and the gray is the unsalted, the blue is the salted, and this spider plot, I think everybody is probably familiar with. The distance between that red dot and the comparable blue or gray dots, it says how different they are. And basically, if you look at that red dot and go over to saltiness, you see obviously if you add salt, it makes it saltier. But notice that it tends to make it sweeter, it tends to increase thickness, it tends to increase fullness, flavor strength, balance, whatever that is, and reduces bitter and metallic. In other words, it makes a profound positive effect on it's not just saltiness, it's making it better. We studied this in a much more simple way, looking at salt's interaction with bitter, and there's good evidence to suggest that salt, and particularly the sodium part of salt, is able to modify the receptor such that it is inhibiting bitter taste. And we know for a variety of reasons, although we don't know the exact mechanism, that this is at the level of the bitter receptor. So if one looks at salt inhibiting bitterness, these are a group of bitter compounds. Some of them are inhibited more than others, and I'm going to talk about the one right in the middle there, urea, which is profoundly suppressed by salt. And again, this is the sodium part of salt, and it's at the receptor level. So what we demonstrated again a number of years ago is that by adding salt, therefore, to a mixture of bitter and sweet, one can actually make that mixture sweeter. And if you look at the left bar, that's the sweetness of sucrose. At the middle bar, the red one, that's the bitterness of urea. When those two are mixed together at the same molar concentrations they were in the first two bars, they suppress each other, and this part of suppression is probably going on in the brain. But if you add salt to it, what you do is you suppress the bitterness, that releases the sweetness from suppression and makes the whole thing sweeter. So this is, I think, just one kind of mechanism by which salt can modify foods in ways that are distinctive to particular foods and particular cuisines. Now, one obviously hope is that one could come up with a salt substitute that would be sodium free, presuming sodium is the thing we want to reduce. And I think that that's going to be a very, very difficult thing to do. If we look again at the receptor, and I remind you about how the receptors differ and how specific the salt receptor is, and this is illustrated in the next slide, which if we look and compare with sweeteners, these are compounds all sweet, some are obviously bitter and sweet, some are off sweet, but many compounds are sweet, some natural, some not. But if you look at the primarily salty substances, very few things are sweet. And I think this is consistent with the idea that this salt taste receptor, the ENaC, the channel, is very specific to the sodium, the lithium ion. They're obviously similar. And KCl is an interesting point, which I don't have time to discuss, but we don't really understand why KCl is salty, but it's also, for many people, bitter or unpleasant. It's not bitter, it's bad. But so in my judgment, we are never going to find an aspartame of salt. It just won't exist because of the mechanism of reception. However, that channel can be influenced by something that might enhance salt taste, and this is an example from some of my colleagues demonstrating that there is, at least in theory, the possibility of developing, and in practice now, enhancers for salt, so that the same level of salt can be made to taste saltier by adding something that itself is not salty. And that's what this shows, that L-arginine HCl added to low levels of salt increase the saltiness. But it only works at low levels, unfortunately. The last
Gary,
thing
I just want to give you a 2-minute time check.
The last thing I want to mention is something that's not a sensory thing, but I think is worth talking about, at least thinking about. And this is, if you remember, I said the average, I quoted somebody, the average amount of salt consumed is 8 to 12 or 15 grams a day. If one looks back at across cultures, one finds that this number comes up time and time again. And here's the oldest known estimate, and it's very, very rough, but it comes out 300 BC to 7.5 grams of salt per day. Here's some other estimates. Again, these are very, very rough, but again, are remarkable about the same levels of salt in these cultures that are independent and very, very old. Here's a nicer study, much more recent, but still old, looking at a variety of different cultures. And this is used to show that cultures where people consume very low sodium, they have very little hypertension. But my interest is on the far right, that most of the cultures that were looked at consume, again, about the same amount of salt. Now we think about this slide again, and that most of the salt comes from, in the US, a wide variety of foods. And the concern is, of course, that somehow we can't get away from it. But is there something else driving how much salt we consume? And these are some data I just recently took from a paper. Along the bottom level is the percent of discretionary salt consumed. That is the percent for these various countries all over the world. The percent of the salt consumed by an individual is added by the person at the table or cooking or whatever. In other words, it's not like in the US, it's not bought. Whereas in the US, we can see that the percent discretionary salt, and I've got it indicated there, is very low, whereas in India, it's very high. And on the vertical axis is the amount of salt consumed. And I can't attest that these are good estimates of salt intake per country. But what you can see is that the percent discretionary salt is actually consumes more salt than in the USA, where where the percent is very, very low. So it's hard to argue that the reason we're consuming so much salt is because of the way that salt is presented to us in all our foods. I'm going to skip this slide. So we don't know the basis for this relatively constant amount of salt consumed, but it's curious and I think worth looking at, because it may be that there's something about driving this level that we as yet physiologically don't understand. So my overall conclusions, leaving out that last very speculative issue, is that indeed population-wide reductions of salt will enhance health and save lives. In cultures like ours, obviously, the strategy has to be reducing it in the manufactured foods. But in cultures where they're still consuming as much salt as we consume or more, but it's being added at home or by the cook, very different strategies have to be used, and this has to be kept in mind. And I believe that the myriad mechanisms and functions of salt in food makes this population-wide reduction particularly challenging. Thank you very much.